Digital codes in computer fundamentals. So we are going to see about the different types of digital codes in computer fundamentals. So for the first one, we have binary code. So binary code is a system of representing data using only two digits, typically 0 and 1. This system is the basis of all digital computing and is used to represent text, images, and other type of data in computer. Understanding binary code is essential for anyone interested in computer science or programming. So this is the basic form of representing digital codes. So binary code is the digital code of the basic computer fundamentals. Okay. So how binary code works? Binary code works by using combinations of zeros and ones to represent different values. Each digit is a binary number is called a bit, and the value of the number is determined by the position of each bit. For example, the binary number 1011 represents the decimal number 11 because it has 1 in the 8th place and 0 in the 4th place, and 1 in the 2th place and 1 in the 1st place. So this is how binary code works. Next up, we have ASCII code, ASCII code. ASCII stands for American Standard Code for Information Interchange. It's a character encoding standard that assigns unique numeric codes to represent text characters. It was first developed in 1960s and it is still widely used today. So ASCII code is the short form for American Standard Code for Information Interchange. It's an encoding standard that assigns unique numeric codes. So it has a unique numeric codes for each text characters. History of ASCII. ASCII was first developed in 1960s as a way to standardize the representation of text characters in digital communication. It was based on earlier character encoding systems such as baud code and Morse code. So we have a table for ASCII over here. So you can take a slight reference from that, and you can see the ASCII table is commonly used for reference for these codes. There are 128 different text characters including letters, numbers, and symbols. Next up, we have Unicode. Unicode is a computing industry standard for the consistent encoding, representation, and handling of text expressed in most of the words writing systems. It provides a unique number for every characters, no matter what platform, device, application, or language is used. So Unicode is a universal code in the computing industry for encoding, representing, and handling of text expressed. So we have words that a text that expresses in the form of Unicode, which is widely used for every platform without any problems. And next up we have gray code. Gray code, also known as reflected binary code, is a binary code system where two consecutive values differ by only one bit. It is commonly used in digital communications, error correction, and electronic circuit design. So gray code is also known as reflected binary code. So the binary code system where the values differ. So we have the great difference of gray code is it has a small difference in the values by one bit. So the two consecutive values differ by one bit, which is the gray code and the binary code. Applications of gray code. Gray code is commonly used in rotary encoders, which are devices that convert rotational motion into digital signals. It is also used in digital to analog converters, where the output voltage is proportional to the input digital code. In addition, gray code is used in error detection and correction. It also allows for single-bit errors to be easily detected and corrected. Next up, we have BCD, binary coded decimal. BCD is a binary coded decimal that represents each decimal with a binary code. It is used to represent decimal numbers in digital circuits and electronic devices. Each decimal digit is represented by a 4-bit binary code, which means that a single byte can represent two decimal digits. BCD is used in applications where decimal arithmetic is required, such as financial accounting systems. BCD is less efficient than other binary codes for arithmetic operations, but provides greater accuracy and precision. And next we have Morse code. Morse code is a method of transmitting text information as series of on-off tones, light or clicks that can be directly understood by a skilled listener or observer without any special equipment. So Morse code is a method of transmitting text information as on-off tones, lights or clicks. So it's a physical method of coding. Hexadecimal code. What is hexadecimal code? Hexadecimal code is a base 16 number system that uses 16 different digits to represent numbers. These digits include the numbers 0 to 9 and the letters A to F. Hexadecimal code is commonly used in computer programming and digital electronics as a shorthand way of representing binary numbers. So we have numbers from 0 to 9 and letters from A to F. These are used together as hexadecimal code. So why do we use hexadecimal code? Hexadecimal code is a more compact way of representing binary numbers. It is easier to read and write than long strings of ones and zeros, and it's easier to work with computer programming. Hexadecimal code is also useful when working with color values in web design, as it can represent a wide range of colors using just 2 digits for each color channel, red, green, and blue. And finally, we have the Hamming code. Hamming code is a linear error correcting code used for transmitting data over reliable channels. It adds extra parity bits to the data to detect and correct errors. How it works? So we have the explanation for how Hamming code works. Hamming code adds extra parity bits to the data to detect and correct errors. The number of parity bits depends on the number of data bits. The parity bits are inserted at specific positions in the data word and are calculated based on the values of the data bits. If an error occurs during transmission, the receiver can use the parity bits to detect the error. If a single error bit occurs, the receiver can correct using the error using the parity bits. If more than one bit error occurs, the receiver can detect the error but cannot correct it.